MAP4C 1.6 Problem Solving with Oblique Triangles. In this section, what we're going to do is apply all of the trigonometry techniques that we've learned to solve for missing side lengths and angles in triangles. So starting off with contrasting each of the different techniques that we've learned. Pythagorean Theorem and primary trigonometric ratios both involved right triangles, meaning that it contains a 90-degree angle in each case. So we will look at Pythagorean Theorem first. This is a relationship between three sides of a triangle. No mention of an angle, so it's the relationship that a squared plus b squared, these two areas add up to the square area of the hypotenuse c. And remember that we need to substitute c in as the hypotenuse when we're using this equation. So this equation can be applied when two out of the three sides of a triangle are known. Next, primary trigonometric ratios do involve an angle theta. So theta is just the reference angle, and depending on where it's positioned inside of the right triangle, that will determine where the opposite and adjacent side are. The hypotenuse is always across from the 90-degree angle, but if this is where we've positioned our reference angle theta, the opposite side does not share an edge with the reference angle, and the adjacent side is next to the angle. The acronym SOHCAHTOA allows us to chunk the following information. There are three primary trigonometric ratios, sine, cos, and tan, and it's a relationship of these sides. So, the ratio of opposite and hypotenuse, for example, sine is opposite over hypotenuse. These lengths make up the sine ratio. In SOHCAHTOA, the first letter denotes which primary trigonometric ratio you are using, and OH refers to the opposite over the hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. So this applies to right triangles, and whenever we have two side lengths and an angle with one component missing from that information. Next, sine law and cosine law can apply to both right triangles and oblique triangles, but the previous two examples do not apply to oblique triangles, which means if it doesn't contain a 90-degree angle, we can't use these formulas. So sine law has two different versions, and all that this difference is that a is in the numerator, and a is a side length. Remember that lowercase letters denote side lengths in a triangle, and capital letters are used to denote the vertices. So this is the same relationship, only the reciprocal, or the fraction is flipped. So I think of this as an X pattern where an opposite angle and length is known, and then for another pair of opposite length and angle, one of the components is known. So if there's an X pattern, only one unknown value is included. So that being said, that is when this applies, depending on what is missing. If it's a side length, use this version. If it is an angle, use this version. Just makes isolating the variable easier. Lastly, cosine law. Cosine law also has two different forms. In this case, C is a side length, it's a lowercase letter, and it's squared. So this is for side lengths. Cos C, this is cos of an angle, so it's pretty close to having an angle isolated by itself, and that is the formula that we'll use whenever we're looking for a missing angle. So here is one example of cosine law. If we have a T pattern, so we can use this formula with this T shape if it's applied in the following manner. A and B are on each side. In this case, this is side, angle, and side are given. That's one of the cases. And the opposite length is known, or is unknown, and we can use cosine law to determine it. A second case is where if this is known and this is unknown, that would mean that we'd have a length, and another length. So three sides are known, we can determine any angle. However, we would have to reorient this T pattern so that it applies to this formula. And we would use angles if we had three sides. So this tree diagram is going to show you the thought process for how can you know which technique to apply. So if we're trying to solve for a triangle ABC, again, solving means to determine every measure of angles and lengths. So the first thing that you can always do is apply the interior angle theorem. The sum of the interior angles of a triangle always add up to 180 degrees, whether it is right or oblique. That can give you some information that may help you apply a different strategy. So if you're stuck, make sure that you're always doing that in advance. It might help you apply. Next, if it's right or if it's oblique, that will be the primary determinant of is it Pythagorean Theorem and primary trigonometric ratios or Sine Law and Cosine Law. Good luck.